Now we're going to talk about grade 10 exponents. Okay, in the previous grades we learned the exponential laws and exponential definitions. Okay, let me just remind the laws. Okay, the law says that when we have like a product a to the m times a to the n, when the bases are common like this, what we do, we just write a, we add the exponents, okay? And then if you have like a to the m over a to the n, and then this can be written as a to the m minus n, okay? And then this formula is, look at this formula 2a and 2b. 2b says a to the m over a to the n equal to 1 over a to the n minus m. But now I want you to notice this. They're useful if when you compare m and n. So this one is useful if m is greater than n, and the following is useful when m is lesser than n. Okay. And then a to the m raised to the power of n is like saying m a to the m times n, and then a to the a times b raised to the power of m. The exponent here is for both for all the variables or say all the variables or all the constants within the bracket. Okay, same thing as here, a over b to the power of m. This is for both the numerator and the denominator. Now, I like to put another definitions of a law of exponents there. When we have like a to the power of 0, this equal to 1. This means any number raised to the power of 0 is just equal to 1. Okay, and then now x to the negative n equal to 1 over x to the power of n. We learned about these formulas, which are they're very useful when we solve laws of exponents. Okay, and then we also have these formulas. Okay, I can say 2, 3, 4, 5, 6, 7, and 8 are very similar to each other, and then 9. When we have like a negative exponent in a fraction like this, we can just say b a over b raised to negative n is the same thing as b over a raised to positive n. Okay, when the exponent is negative, you can switch the fraction, the numerator and the denominator, and then make the exponent positive, and then a to the negative m over b to the negative n is just like as good as b to the positive n. This one comes in numerator b to the positive n over a to the positive m. Okay. The trick is like, it may seem like a lot of things to memorize, but it's not really. I always advise students first write your, have your formula sheet aside, write the formula sheet whenever you feel like you need it, okay? Instead of you substituting in your mind, but to write the formula down. Again, even if you know it, just write it down and then substitute following the formula. This is one of the ways you can trick your brain to memorize the formula without you doing lots of effort memorizing them. Okay. Now let's dive into exercises of what we did in the previous grades. Now, question 1. Here the question says simplify. Okay. So I'm gonna do that by the help of the formulas we listed above. I'm gonna write here question A1 here. I'm doing 1. We have like p2 p to the power of 3 multiplied by 8 p squared. Now, what can we do here? You know, for the constants I'm referring to 2 and 8. Okay, those we can just times the constants, and then this will be equal to 16. And now the variable here will like p but raised to the power of 3 and then p raised to the power of 2. In this case, we remember the formula that says a to the m multiplied by a to the n, and this is equal to a to the m plus n. So we're going to apply this formula here. Over there, we will say p but raised to the power of 3 plus 2. And then the answer is just 16 p to the 5. Okay. Same way, you can do question 2 and then question 3. Okay. Let's do them. Question 2 says Equation 2 was equation 2 was 6x squared y to the power 3 multiplied by 6x y to the power 4. Okay, let's first calculate the constants, 6 and 6. Okay, 6 times 6 makes 36. And then the variables here, we have two different variables. X is raised to the power of 2, and then x here, we don't see any exponent. Okay, when you don't see any exponent, understand that the power is just 1. So over here, you can just write x, and then what you do, you add the exponents, okay, applying this law of exponents. So we're going to do 2 plus 1, okay, and then for the other variable, y, we have like y to the power 3 and then y to the power 4. Then again here we just want to see y there, and then we're gonna do 3 plus 4. Now the answer here would be 36, x to the power 3, y to the power of 7. Okay, and then question 3, there was 2 to the power 5 multiplied by 2 to the power 3 multiplied by 2. Now I said, whenever you don't see any exponents, okay, understand that the power is just 1. You can substitute it by 1 there. Now, the fact that the bases are common, you can see that this is 2 here, this is a 2, and this is 2. The bases are common. We can apply this law, okay? A to the power of m multiplied by a to the power of n multiplied is something else dot. So this will be you can just write 1, 2, and then we do 5. At the numerator there we do 5 plus 3 plus 1, and then this equal to 2 to the power of 9. Okay, and then question 4. We have like 9 to the 4 multiplied by 9 to the 3 multiplied by 3 multiplied by 3 to the power of 2. So in this case, it is important in cases like this, because you notice that these two have common base, but not all of them have common, because there we have a 3 there. The bases are not common. We cannot really apply this formula of a times m multiplied by a times n equal to a to the power of m plus n. Now, it is most of the time useful to always reduce, okay, each basis in terms of its prime factor. The prime factor is what you learned in previous grades. It's like you can use factor 3. You can write like 9 like that, and then you do by 3, it's 3, by 3, it's 1, and then you say, oh, 9 is like 3 times 3, which is 3 squared. Okay? Or you can identify them also by the help of a calculator. If you do, over here, you do like write the number 9. Over here, you just press 9, okay, and then you hit the equal button, and then press shift, and then press this button here, you see fact, okay, and then it will tell you what the number is in terms of its prime factor. Let me do it over again. So like, I take a number like 9, you press 9, you need to find the prime 9 in terms of its prime factor. You press this button, the equal button, press the equal button, and then press the shift button over here. You press the shift button, and then you can press the button that you see here. You see on top there is written fact, okay? When you hit there, it tells you what the number is in terms of its prime factor, 3 squared. Now, we will going to reduce each term in terms of each basis in terms of the prime factor. And then I will write like it was 9 to the power 4. I'll keep it like that. And then 9 to the power 3, and then 3 squared. Now, if I reduce 9 to the power of 4, it's going to be like 3 to the power of 2, and then 3 to the power of 2. Now, there is a law of exponent that will intervene over here. Let me erase this. The law of exponents, one of the law we learned says like a to the power of m raised to the power of n, okay? This is equal to a to the power of m multiplied by n, okay? So in this case, this is the law we're going to apply, and this will be 3 to the power of 8 multiplied by 3 to the power of 6 multiplied by 3 to the power of 2. Now that the bases, as we see, are common, okay, we can just add the exponent, and then we can say 3 equal to 3 to the power of 8 plus 6 plus 2. Okay, this is just equal to 3 to the power of 16. 3 to the power of 16. And then I take another example, another question, question 5. Over here, question 5 says 7 squared multiplied by 7 squared multiplied by 7. So I'll leave that one for you. Understand that here the power is just 1. So if I leave that for you to practice, and I'll move to question 6. Question 6 here is 7 squared plus 7 squared plus 7. Okay, maybe let's just do question 5 as well. Over here, notice that the bases are common. Okay, we have 7, 7, 7 there. According this law of exponents, a to the m multiplied by a to the n equal to a to the m plus n, we can just say write 1 7 there, okay, and then add the exponent. So we'll do 2 plus 2 plus 1, and then this is equal to 7 to the power of 5. Now look at question 6 here. Again, over here the exponents, we don't see any exponents, it's a 1 there. Now, but there's one thing I want you to pay attention on is the algebraic operation. This is not a times, but this is an addition, okay? So we don't have a property here for the addition. This property is for, this law of exponent is only for when we multiply variable with some basis or constant with some basis, but this is addition. Now in this case, what we do, okay, we can say there's a different way to solve this. I can go with the fact that these two are same, 7 squared, 7 squared. 7 squared plus 7 squared can be, is 2 7 squared. So 2 times 7 squared plus 7. Okay? So it's like 7 squared is 49. 49 times 2 is 98. 98 plus 7 will be 105. Okay, 105. We can do that. Or we can also say split this like 7 squared. We can write it's like 7 times 7 plus 7 times 7 plus 7. Now we can take 7, which is here the common factor. Okay, so it's gonna be like we can take 7 out as a common factor. So 7 factor of what? Of 7, because if I take 7 out as a common factor, I left with 7 here, and 7 here, and then there will be 1, because 7 is like 7 times 1. Here it's like times 1. Okay, so it's going to be like factor of 7 plus 1. So this will be equal to what? 7 plus 7 plus 1 makes 15. And then we can do 7 times 15, which is equal to 105. It's also another way of solving this problem. Okay. Let's take another question. I'll take question 8. I'll leave question 7 for you to practice. Yeah, I'll leave 7, 8, 9, 10 because they're similar. So let's show the questions. These questions are very similar. 7, 8, 9, 10. I'll leave them out. Okay. Then I do question 11. It's like 3 to the power of 2 times 2 squared. So in this case, note that the bases are not the same, are different, but the exponents are the same. You can solve this by, because the exponents are the same, we can put it like this, to the power of 2, and then there we write like 3 times 2, because exponents are common. Remember that law that says a times b to the power of n. This is equal to a to the n multiplied by b to the n. And then those laws are useful from left to right and as well as from right to left. Like in this case, we have like a to the n multiplied by b to the n, and then we transform it to a times b raised to the power of n. We can do that, okay? And then this is equal to 6 squared, which is equal to 36. Or we can just work out 3 squared is 9, 2 squared is 4, and then it's equal to 36. Okay, and then I'll leave question. This is similar like question. Okay, let's do question 12. When we have like 4 times 2 to the power 3. Okay, we can say 4 multiplied by 8 because 2 to the power 3 is 8. Okay, and then we get the answer 32. We can do that. Okay, or someone else may transform 4 in terms of its prime factor, and then let's see, or we can do 4 is like 2 squared, and then 2 to the power 3 over here. We can apply the law of exponents, a to the n times a to the m. This is equal to a to the n plus m, and then this will be like 2 to the power of 2 plus 3, and then this equals to 2 to the power 5, which is 32. Okay, and then question 13. Of what are called I think I jumped question 10. Question 10 was is a to the power of 8 multiplied by a to the power of 8. So in this case, yes, we can write a to the power of 8 plus 8, but I believe the best way is to reduce. Of course, okay, the bases are common here, so we can just write 8 to the power of 8 plus 8 is 16, and then we can even write it better. You know, 8 is 2 to the power of 3. Okay, we can simplify it. That makes 2 to the power of 3 8. So it's just one of the way of solving this. Now let's take question 13. Then question 13 is 3x to the power of 3, y to the power of 5 to raise to the power of 2. Okay. Now we did wrote the law of exponent that says a times b to the power of m is equal to a to the m multiplied by b to the m. Okay, the exponent outside the brackets is for everything, each constant and variable within the bracket. So this will be equal to, I prefer to write it this way, around equals, and then I prefer to do this. Okay, 3 squared, x cubed squared, and then y to the power 5 squared. Now I can write my values there, 3, okay, and then x cubed, and then y to the power 5. Now we have another law of exponent that says a to the m all to the power of n. This is equal to a to the m multiplied by n. And then this will be then 3 squared. This is why I can apply this law, this one. That makes x to the power of 6, and then y to the power of 10. Okay. That was question 13. We can also do question 14. 14 says like 2 open bracket 2a raised to the power of 2a squared, okay, raised to the power of 3. So in this case, we're going to write 2 multiplied by this part. We're going to apply this law, okay, because this means we have okay, I'm gonna put this cube and then cube there. That's gonna be like 2 to the power of 3, and then a squared to the power of 3. Now this will be then note that here, when we don't see exponents, understand that the power is just 1. Over there, we will going to add the exponents, just makes 2 to the power 4, and then 8 to the power 6. Over here, we apply this law of exponents, okay? And then question 15. Okay, I can leave question 15 because it's really it's like, okay, let's do question 15 and then I can leave the others. So it's gonna be like 3 2a squared b to the power 3 raised to the power of 2. Now, as we said, our law says that a times b raised to the power of m. This is equal to a to the m multiplied by b to the m, okay? So over here, the exponents is for each term, okay, within the square bracket, okay? This would be like 3 raised to the power of 2, okay? And then 2 raised to the power of 2, a squared to the power of 2, and then b cubed also to the power of 2. And then this would be just 3 squared times 2 squared times a to the power 4 times b to the power 6. And then this can be reduced to 3 squared is 9, 9 times 2 squared is 4, 9 times 4 is 36. So 36, a to the 4, b to the 6. Okay. Now let's see other questions. Other questions are very similar to the previous question. 13, 14, 15, 15. Yes, I can leave this one 16, 17, 18 because they are much similar. So I'll move on to question 19. Question 19. Question 19 says x to the power 5 over x to the power 3. Okay, note that the law of exponents says that a to the m, let me write it over here, a to the m, okay, over a to the n. When the bases are common, we can work it out, we can simplify this. This is like a to the m minus n, and then it is useful when m is greater than n in this case, okay? A similar one is like a to the m over a to the n. This then, we're going to write that at the denominator m, a to the m minus n, under 1 like that. This is when m is lesser than n, okay? Now in this case, first the bases are the same. We can apply the law because it's like a, the form a to the m over a to the n, okay? The bases are the same. Now we're going to look at the exponents. This is 5 and this is 3. Because it is 5 is more than, this is like the m, okay? This is like the m, and that is like the n, okay? And then this is like this, m is greater than n, then we can just say this is equal to 1x to the power of 5 minus 3. And then this is equal to x squared. Okay, but now let's look at question 20. Over here we have like x to the power of 5 over x to the power of 20. Now in this case, first of all, the bases are common, so we can apply this law of exponents. And then we're going to look at the exponents then. We have 5 and then 20. So here the numerator m is lesser than n. Okay, so we're going to apply this one. Over here, the answer will just be equal to 1 over x to the power of 20 minus 5. Then this will be equal to 1 over x to the power 15. Okay, but sometimes people you'll see sometimes most people just use this formula for all of them, and I'll tell you why. Sometimes this is actually the main formula, okay? In question 20, here I can still do x to the power of 5 minus 20. And this is equal to x to the power of negative 15. This is right. But now we don't leave our answers with a negative exponent. This is where I need to apply another law of exponent that says a to the negative m, okay? This is equal to 1 over a to the power of m. Now in this case, we can just write, okay, 1 over x to the power of 15. Okay, we'll leave question 21 and 22 for you to practice, and then I'll do question 23. 23. Question 23 said like negative 12 a to the power of 14 over negative 18 a to the power of 6. So in this case, we can solve this by simplifying, you know, the negative and negative can be simplified. Okay, negative over negative is positive. Okay, and then we can simplify also 12 and 18. You know, when we simplify them, we get like, we can divide them by 3, and then that's gonna be like, no, by 6, I mean, and then that's gonna be 2, and then that's gonna be 3, and then we can write here 2 over 3. Okay, we work out the constant first, and now a to the power of 14. Okay, 14 minus 6. So this is equal to 2 over 3 a to the power of 8. Okay, we can also do 24. There we have like x to the power of 40, y to the power of 16 over x to the power of 36, and then y to the power of 20. So in this case, we notice that we have same basis here, x here and x there. So because they're same basis, we can write just 1x here to the power of what? Of 40 minus 36. We can do that. Okay. And then over here, we have also same basis, but now when I look at the exponents, 20 is more than exponent 16. I rather move this one at the denominator, okay? X to the power of 16 to the denominator. This will be y to the power of 20 minus 16, okay? And then this will be equal to x to the power of 4 over y to the power of 4. And then note that the fact that the exponents here are common, we can just say x over y to the power of 4. Okay. Now, if for instance someone said over here, he would write x to the power of 40 minus 36, and then multiply by y to the power of 16 minus 40 minus 20, then it will have to reduce that again, because this will be like x to the power of 4 multiplied by y to the negative 4, and then over here he has to apply this law of exponents to move y to the negative 4 at the denominator. So this will be like x to the power of 4 over y to the power of 4, and then do simplify it to this form. Okay. Thank you. So I'll leave the rest of the questions for you to practice. These other questions, where are them? Question 25, I mean, yeah, 25, 26, and 27. Practice them, follow the same law of exponent that we use. Thank you. Please, if you like our videos, if you like our content, subscribe to the channel and like the video. And don't forget the notification button. Thank you.